Hi, welcome back. Today, the case study on why the transformer it won't work on DC power supply. So, normally the transformer it is works only on AC. Why it is not work on DC power supply? So, before going into this case study, first of all we have to know what is transformer. We know what is transformer. So normally the transformer is nothing but a static device which is used to transform the energy from one circuit into another circuit without changing the frequency, so that we can able to regulate the voltage. We can able to adjust the voltage level. We can whether we can able to step down the voltage or we can step up the voltage. Okay. So may I know what is the working principle behind this transformer operation? Mutual induction. Faraday's law of electromagnetic induction, especially mutual induction. May I know what is mutual induction?
When the nearest coil is magnetized or electronized, the corresponding coil will also get magnetized.
Yes, very good. So, just like if I am giving the power supply only to the primary winding, but I am getting the output in the secondary. It's because of mutual induction. It's because of I am giving the power supply to the primary. I am getting the power from or the power output as from the primary is right, but I am taking the output and the secondary. So I am giving the input to the primary, but I am getting the output in the secondary. So because here the mutual induction principle will appear. So that from the primary, the produced flux from the primary winding that will interact in the secondary winding, so that there will be an EMF induced across the secondary winding. Okay. So in a transformer, it consists of two winding. One is called a primary winding, another one is called secondary winding. So the primary winding which is connected with the power supply, that is nothing but source, and the secondary winding which is connected with load side. Okay. So both are it's made up of copper. So the coils are mounted on the limb. It is called limb on transformer core. The transformer core is made up of silicon steel material. It consists of n number of stamping, just like our paper note. It will be thin laminated one. Okay. So initially, if the power supply is switched on, the current starts flowing through the primary winding. So the primary winding is getting excitation. So it acts as an electromagnet. Then it starts producing the electromagnetic fluxes. So the produced flux it starts flowing from primary to secondary. Then at that time, what will happen in the secondary winding? EMF will be induced. At what condition the secondary winding is inducing the EMF? At what condition? When the EMF will be induced in the secondary winding. When the EMF will be induced in the secondary winding. At what condition?
When the primary winding is
when the primary winding is getting energization and it starts producing flux. At what condition the EMF will be induced in the secondary winding? At what condition? What is that? Change in flux. When the flux is getting changing, so that only the EMF will be induced. We have to get alternating flux, change in flux. If the flux is constant, we won't generate any EMF. Okay, the induced EMF will be 0. So only if the flux is getting changing, so that only the EMF will be induced in the secondary winding. Because in AC, it is an alternating current, positive half cycle, negative half cycle, positive, negative. Just like that, the cycle is getting always changing in every second. So in per second, around 50 cycle will be there. So in every second, 50 positive half cycle and 50 negative half cycle will be flowing. So here, at positive half cycle, the flux will start flowing like in this direction through secondary winding. And during the negative half cycle, again it will gets reversing because the polarities gets changing. So during the positive half cycle, the produced flux it starts flowing from primary to secondary in this direction, and during the negative half cycle in the opposite direction. So through the secondary winding, the flux direction is always getting changing. The flux direction is always getting changing across the secondary winding. So the change in flux across the secondary, it induces voltage. It induces some voltage. Because of the induced voltage, there will be a current in the secondary winding. That current will be taken into the. So this is the general operation. I am giving the power supply to the primary, then it will start producing flux that will be taken into the secondary winding through transformer core. here there will be a change in flux because of alternating flux. So the EMF will be induced, that will be taken into the load. This is the general operation. Okay. So now I am giving the AC power supply, it will be happen. Suppose instead of AC, I am giving DC power supply. So what will happen to the transformer? What will happen? Whether it will work on or not? It won't work. May I know why? Any reason behind is that?
The frequency of DC current is 0.
The frequency of the DC, the frequency in DC is 0. Okay, if frequency is 0, so how it affect the transformer operation? The frequency is 0, it is right. If the frequency is 0, so how it affect the transformer operation? Any idea?
As a transformer works in a constant frequency, if the frequency is 0, there will be no.
So the transformer, it works on constant frequencies, right? It works on constant frequency. Okay. So here, normally a transformer it consists of two winding. It is made up of copper. It is made up of copper. So the impedance of the winding, it is the combination of resistance in the winding plus the imaginary part of the reactance. Especially it is a coil. So this reactance is called inductive reactance. Because of the coil, so it is called inductive reactance. So the impedance is the combination of resistance and the reactance. So that is nothing but inductive reactance. So here, what is the formula for inductive reactance? To calculate the inductive reactance, what is the formula? 2 pi Fl. So 2 pi Fl is the formula to calculate the inductive reactance value. Okay. So in a transformer or in any kind of motor winding or generator winding, so there are two parameters. One is resistance and the reactance. So the resistance, what is the property of resistance? It opposes the flow of current. But if you go for the winding, the resistance will be very low. And the reactance is very high. Okay. So what is the property of reactance? The property of reactance which is used for the resistance, it opposes the flow of current. And what about the reactance? What is the role of reactance in the transformer? What is the use? If the reactance is high, what will happen?
Output current is
If the reactance is high, the produced flux is also high. So the reactance which is helping to produce high flux. If the reactance value is low, it produces small amount of flux only. So it is with respect to the flux production. Okay. So here in DC circuit the frequency is 0. So 2 pi Fl. If frequency is 0, so what about the value of inductive reactance? The inductive reactance value will be 0. So the impedance is the combination of resistance and inductive reactance. If the inductive reactance is 0, so the impedance which is equal to R. That is nothing but only resistance. The impedance which is equal to only the resistance, because the reactance value is 0 in a DC circuit. So what is the value of resistance in the transformer? Whether it's high or medium or low? In a transformer, what is the resistance value? There is low, medium or high value? Low value. Very low value. Okay. So in a transformer, the resistance is very low. In a transformer, the resistance is very low, and there is no reactance. Okay. Now you can imagine. Now I am supplying very large amount of current through this coil, through this primary winding. Okay. Now I am supplying large amount of current through the primary winding. The primary winding, it consists of only resistance, that too very small value. Okay, so if I am supplying high current through low resistive value, so what will happen? It is unable to withstand. Because it is not capable to hold that much amount of current. Because we are supplying a huge amount of current, because it is a minimum resistance value, so it won't withstand. So automatically the coil gets breaking. Before that, the coil is getting overheating. Because we are supplying huge amount of current. Because of this huge amount of current, the coil is getting overheated. Because of this overheating, automatically, if getting overheated, what will happen? It gets blasted. The fire accident, just like fire accident, it will get fire, it will get blast. Because of overheating, it will at certain time it won't work. That is why it will blast. So because the main reason, in a DC circuit, in a DC, frequency is 0, so indirect reactance is 0. So the impedance is purely resistance. The impedance is purely resistance. That was too small value. So it is unable to hold the high current. So that it is because of overheating, it won't work on DC. It will blast. The fire accident definitely will occur. Because of overheating, it will be created fire. It created short circuit. Okay, so that's why the transformer won't work in DC. Any idea is there? Any doubt is there?